Hey everyone, in today's lesson we're going to be talking about this thing called the unit circle. So let's look at this word unit circle, or two words right here. We obviously know what a circle is, so that's what a circle. But what is this unit all about? Well, if I actually draw over here a graph grid, and I'll just do a very small graph here. Each one of these numbers is actually a unit. So this is 1 unit, 2 unit. And so if I draw a tiny circle right here with a radius of 1 right there, so if that's radius of 1, that is actually the same thing as this circle right here. So if I zoom in for this circle to here, that's what this big old unit circle is, because it has a radius of 1. So I'll draw the same thing. So if I go like this, that highlighted part that I drew on the graph right here is the same radius right here. So that means that this radius right here is equal to 1. So what does that mean about this point right here at the tip? Well, that point right there is the same thing as this point right here. And we know that the coordinate pair for that is 1, 0. So we can fill this part of the unit circle 1, 0. All right, awesome. So if we look at the unit circle, there are a few parts. So we have these things. Okay, each one of these are coordinate pairs. Coordinate pairs. And then we also have this thing right here, and you can see the symbol right here. These are the degrees. The angle, so these are, maybe I'll do it over here. So each one of these things are degrees for the angle. And actually there's one more right here, this empty space. This is actually for another measurement of angle called the radian. And we will fill all these out. So let's actually start with the degrees because we're most familiar with this. So on a unit circle, well, let's see, let's actually talk about a clock. You know, in a clock, we typically start right here at the top. We would kind of say that that's the beginning, right, at 12. And then the clock moves in this direction, which we call clockwise. So again, we start at the top, and then it moves down clockwise. Well, for a unit circle, the starting point is actually over here, this radius that I drew. That's the starting point, and it moves in this direction. The opposite way, it actually moves counterclockwise. Counterclockwise. Okay, so what do I mean by that? Okay, so if this is the beginning, we'll say that this is 0 degrees. 0 degrees. Now, if I sweep from this angle all the way to maybe right here, so now I go from here to all the way here, what angle is that right there? Well, that is a 90-degree angle. So what we can do is say right here at the top is 90 degrees. And I'll just erase these two. Okay. If I do it again, starting from the beginning, if I sweep my way all the way over to here, then my new angle over here, that would be 180 degrees. So I'll put 180. Okay. Yeah, and then erase this right here. And if I keep going, what if I sweep all the way around? Then that would take me back to my start. We know that would be 360 degrees. So I'll just write right under here 360 degrees as well. Okay, so why don't we just fill out the rest of the degrees on this unit circle? So if you think you can figure this out, pause the video and give it a shot. If you want to just follow along, here we go. All right, so we know that this is 0, the top is 90, then 180. So if we go 90 more degrees, then we would add 90 to 180, which would make this 270, 270 at the bottom. All right, so I got all my corners done. So now let's do this next one then. So if this one is 90 here, maybe let's erase this here. If this angle is, if this angle is 90 degrees, then what if we do half of that angle? Well, we know that if we sweep from the beginning to here, that must be 45 degrees, right? Because it's half of 90. So I'll write 45 here. Okay, so now what I'll do is I'll just count by 45s now. So I have 0 degrees, 45, and 45 plus 90, or 45 plus 45 is 90. 90 plus 45 will get me 135. And then 135 plus 90 is, 135 plus another 45 degrees is 180. And 180 plus another 45 degrees will get me 225. And then from there, another 45 degrees gets me 270. And then from 270, another 45 degrees will get me, 315 degrees. And then if you add another 45 degrees back to the beginning, it should add up to 360. So that's how you get the middle degrees. All right, so the last ones we need now are these ones in between. Okay, so if we look at this geometrically, we can tell that if this is 90 degrees right here, 90 degrees, I'll do a different color. If this is 90 degrees here, then if we look at these angles right here, it looks like they are broken up into 1/3. So 1/3 here, 1/3 here, and 1/3 here, right? So that means we can take this 90 degrees and cut it up into 3 parts. So the only way to do that would be to make each of those 30 degrees then. So what I'll do is, let me erase so I can give myself some space here. I'll say that this is 30 degrees. And then 30 plus another 30 would give me 60 degrees. And then if I add 30 again, that brings me back to 90 degrees, right? So why don't we keep going? So, oops, this went away. So I have 30 plus another 30 is 60, plus another 30 is 90, and then 90 plus another 30 degrees is 120. And then 120 plus another 30 degrees would be 150. And 150 plus another 30 degrees is 180. Plus another 30 degrees gives me 210, 240, 270. Another 30 degrees gets me 300. And finally 330. If you did it all right, 330 plus 30 again gets me back to 360. Awesome. Let me just clear this up. Get this all out of the way. Rest there. Okay, so let me bring back my original start point. Okay, awesome. So we've completed all the degrees. We're done. Awesome. Okay, let's move on to radians. So let's remind ourselves, what is a radian anyway? So up at this corner here, I'll erase this clock. So a radian, to remind ourselves, is if we have a circle, a radian is a measurement of an angle. So let's say we have a radius here. If we take that same length of a radius and wrap it around the circle, so that's the same length right there, same length. And then we make an angle out of it. So let me zoom in here. And we make an angle out of it right here. That angle is 1 radian. Very clever name, right? Because you use the radius to create an angle. So that's 1 radian. So the question is, well, we know in a circle, if we go from the start and rotate all the way around, we know that is 360 degrees, right? Well, our question is how many radians is the same thing as 360 degrees? That's our question. Well, if I were to kind of draw this out and guess, so that's 1 radian, there's another radian, 2 radians, 3 radians, right? If I were just to estimate 4 radians, or 1, 2, 3, 4, 5 radians, 6 radians. So it's about 6, but you know, my circle's not great. But turns out there's about 6 radians and a little bit more. So it turns out that it's a full circle is exactly, and I'll write this here, it's exactly 6.28, which is basically like 2 pi radians. So this is something that we really need to remember for this unit circle. Okay, so now that we got that, let's fill out some information. So we said that this is the radian slot, so let's write 0 radians for that. 0 because we haven't moved yet. And we said a full turn is 2 pi radians. So let's write that. This is 2 pi. 2 pi. All right, so let's do a little bit of fraction math now. If we know that a full turn is 2 pi radians, then what is half a turn? Well, we must cut the 2 pi in half to make 1 pi. Make sense? Let's do that again. Now, if 1 pi is the half turn, then what is the quarter turn right here? Quarter turn. Well, that must be 1/2 pi. Right? 1/2 pi. And then if we keep going further, then if we cut that in half and only do a 45 degrees, then we cut it in half again, and this must be 1/4 pi. Cool. All right, so yeah, why don't we make a little table at the bottom to help us with our conversion, right? So, hey Google, stop. Okay, so I'm going to do a degree to radian conversion. So I have 0, and we said 45, 90, and I'm going to just keep going. 135, 180, 225, 270, 315, and 360. So what I basically did was I took all the middle values every 45 degrees, 0, 45, 90, 135, 180, and so on. And I just wrote it on this chart. This will help me figure out what all the radian angles are. So we said that at 0 degrees, it's 0 radians, right? I don't need to write radians. And we said at 45 degrees right here, it's 1/4 pi. 1/4 pi. And then at 90 degrees, we said it's 1/2 pi. Okay, now, so here's something pretty cool. We know that every 45 degrees, we grow by 1/4. Right? And it makes sense because what's 1/4 plus another 1/4? Well, 1/4 plus 1/4 is actually 2/4, right? And 2/4 is reduced. If you reduce it, it's the same thing as 1/2. Okay, so let's keep going. 2/4 plus another fourth is 3/4. That's nice. And then if you add it again, it's 4/4. But we know 4/4 is actually the same thing as 1. Okay, so let's keep going. 4/4 plus another fourth is 5/4. And then 6/4. And then 7/4. And 8/4. And so let's simplify some of these. We know 6/4 you can reduce it to 3/2. And 8/4 we know is the same thing as 2 pi. So let's just fill this information in. So we said we have, this is 1/2 pi, which we've done. This 135 we just found out is 3/4 pi. 3/4 pi. Zoom in here. This one was 4/4, and the next one is 5/4 pi. Next one is 6/4, but we said we can reduce it to 3/2. And then the last one is 7/4 pi. All right, awesome. So we got all of that. So our last piece that we need is to get this, the 30 degrees and 60 degrees. So let's make another chart to help us out. So right here, so we have degrees, and then we have 0, and we're going to go up by 30 this time. 30, 60, 90, 120, 150, 180, and ... to help us. Let's just do the first half of the circle. So the first thing we need to do is figure out, well, what is this 30 degrees going to be? Well, just like before, when we first found out how we figured out this was 30 degrees, if you remember, what we did was we knew that, actually let me erase some of this to clear this up. We knew that this whole thing was 90 degrees, right? And we saw that each of these slices right here was a third of that entire piece. So we said, okay, if these are exactly a third, then it has to be 90 split into 3 parts. So let's do that same logic again. We have, instead of 90 degrees, we have 1/2 pi radians, and let's split that into 3. If you have 1/2 pi and you split into 3, each piece is going to be 1/6. 1/6, okay? Because half times a third, right? Because we have this 1/2 pi, and we're splitting it up into 3 parts, so times a third. And fractions say you multiply across, so it becomes 1/6. Okay, so we just figured out that this one is 1/6 pi. Let's write that down. 1/6 pi. So, oops, sorry, that is not for that one. That's for this one right here. And we know the beginning is 0. So let's count. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and on and on. And we can write pi's for each of these. And then let's simplify them. This one, 2/6, can be turned into 1/3. The 3/6 is a half. 4/6 is 2/3. And 6/6 is 1. Okay, so which ones do we need to fill out? So we said this is 1/6. This one was 2/6. But 2/6 can be turned into 1/3. Okay, so that. And we already know 90 is 1/2. 120, okay, so 1/6, 2/6, 3/6, and 4/6. So 2/3 is what 120 degrees is, which is 2/3. So 1/6, 2/6, 3/6, 4/6, 5/6. 5/6. and then 6, 6, 7, 6. Next one is 8, 6, but that can be changed to 4/3. So this is the better one. So 8, 6, 9, 6, right? But 9, 6 is 3/2, which makes sense. Next one is 10, 6, but 10, 6 can be reduced to 5/3. So 10, 6 and 11, 6. And that is that. And we have completed the degree, or degrees and radians. So that's awesome. We did the radians now. Done.